Hello, and welcome back to Science for Sleep. Tonight, we're going to spend some quiet time exploring something that is often misunderstood, rarely noticed, and deeply woven into the way the human mind and body function. We're talking about silence, not as the absence of sound, but as a real, measurable condition that affects the nervous system, the brain, and the way the body settles into rest. Silence is often described as empty or uneventful, but from a biological perspective, it is anything but. When sound fades, the body does not simply stop responding. Instead, it begins to shift. Neural activity changes patterns, sensory processing reorganizes itself, and the brain transitions into states that are difficult to access when noise is present. These changes happen automatically, without instruction, and they begin quietly, often before we are aware of them. Most of the time, the human auditory system is actively filtering the environment. Even when we think we're ignoring background noise, the brain is constantly scanning for meaning, threat, or relevance. This process consumes energy. When sound is reduced or removed, that constant scanning eases. The auditory cortex, which normally processes sound information, begins to slow its activity, allowing other systems in the brain to shift into a more balanced state. Silence also affects the nervous system as a whole. In quieter environments, the body often moves away from heightened alertness and toward parasympathetic activity, the branch of the nervous system associated with rest, digestion, and recovery. Heart rate may slow slightly. Breathing often becomes deeper without conscious effort. Muscle tension begins to release in small, unnoticeable ways. These are not reactions to silence itself, but to the reduction of sensory demand. What makes silence especially interesting from a scientific perspective is that it does not need to be absolute. Even brief moments of quiet, pauses between sounds, or environments with reduced auditory stimulation can trigger measurable changes in brain activity. Studies have shown that periods of silence can increase blood flow to certain areas of the brain and support processes linked to memory, emotional regulation, and internal awareness. Silence gives the brain space to reorganize itself. From a neurological standpoint, silence allows the brain's default mode network to become more active. This network is associated with internal thought, reflection, and the gentle wandering of attention. It is the same network that becomes active during rest, daydreaming, and certain stages of sleep. When sound recedes, the mind naturally turns inward, not because it is instructed to do so, but because fewer external signals are competing for attention. Biologically, this inward shift is not accidental. For most of human history, quiet environments signaled safety. Loud or unpredictable sounds often meant danger or activity, while silence allowed for recovery and restoration. The body still responds to these patterns today, even in modern environments where sound is constant. Silence, when it appears, is interpreted as permission to slow down. In this video, we'll gently explore the science behind these responses. We'll look at how silence affects the brain, how quiet influences neural repair, how the body interprets low stimulation environments, and why moments of silence can feel deeply calming without requiring effort. Nothing here needs to be remembered. The facts are meant to drift softly, offering understanding without urgency. If you enjoy these long, quiet journeys through science, consider subscribing to Science for Sleep And if you'd like, feel free to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm space, one quiet listener at a time. For now, there's nothing you need to focus on. You can let the sounds around you fade into the background, knowing that silence is not empty. It is active, supportive, and deeply connected to the way your mind and body naturally settle when given the chance. We'll move slowly from here, letting the science unfold at the same gentle pace as the quiet itself. When sound begins to fade, the brain does not switch off. Instead, it reorganizes. The human auditory system is designed to be alert by default, constantly monitoring the environment for changes, patterns, and signals that might matter. Even in familiar spaces, the brain continues to listen, filtering layers of sound and deciding, moment by moment, what deserves attention. This process happens automatically, without conscious effort, and it continues as long as sound is present. When that sound is reduced or removed, the brain's workload changes. Neural activity in the auditory cortex begins to shift, not because the brain is becoming inactive, but because it is no longer required to process as much external information. The neurons responsible for decoding pitch, rhythm, and intensity slow their firing patterns. This creates space for other neural systems to become more active, especially those involved in internal processing and regulation. Silence also alters how different regions of the brain communicate with one another. In noisy environments, attention networks remain engaged, ready to respond to sudden changes. When quiet sets in, these networks gradually loosen their grip. The brain moves away from constant external monitoring and toward a more internally balanced state. This transition is subtle and often goes unnoticed, yet it has measurable effects on brain activity and energy use. Research using brain imaging has shown that periods of silence can increase activity in areas linked to memory consolidation and emotional processing. When external stimulation decreases, the brain has an opportunity to replay recent experiences, strengthen neural connections, and organize information more efficiently. Silence does not force these processes to occur. It simply removes interference, allowing them to unfold naturally. Another important change involves the balance between excitatory and inhibitory signals in the brain. Sound stimulates excitatory neural pathways, keeping the brain responsive and alert. In quieter conditions, inhibitory pathways become more influential, helping to stabilize neural activity and prevent overstimulation. This balance is essential for mental clarity and emotional regulation, and silence supports it, without requiring effort or intention. The brain's response to silence is also shaped by expectation. When sound stops abruptly, the brain initially remains alert, waiting for what might come next. Over time, if silence continues without interruption, neural activity adapts. The brain learns that no immediate response is required, and alertness gradually softens. This adaptation reflects the brain's ability to predict and adjust, conserving energy when stimulation remains low. Importantly, silence does not need to be complete to produce these effects. Even environments with reduced noise, steady low-level sound, or long pauses between sounds can trigger similar neural shifts. The brain responds not only to volume, but to complexity and unpredictability. Simpler auditory environments are easier to process, allowing neural resources to be redirected elsewhere. From a biological perspective, this redirection is efficient. The brain is one of the most energy-demanding organs in the body. Reducing unnecessary sensory processing helps conserve resources and supports recovery. Silence functions as a low-demand state, giving the brain an opportunity to reset without shutting down. You don't need to notice these changes for them to occur. The brain adapts quietly, responding to the absence of sound just as reliably as it responds to sound itself. As quiet continues, neural activity settles into a calmer pattern, one that supports rest, reflection, and the gentle drift of attention inward. Silence becomes not an absence, but a condition in which the brain is allowed to rebalance, preparing the ground for deeper calm to follow. Beyond the brain itself, silence has a noticeable influence on the nervous system as a whole. The nervous system is constantly balancing between states of readiness and rest, adjusting moment by moment based on the information it receives from the environment. Sound plays a powerful role in this balance. Loud, sudden, or unpredictable noises signal the possibility of action, while quieter environments suggest safety and stability. When sound diminishes, the nervous system begins to recalibrate. The autonomic nervous system is divided into two primary branches. One supports alertness and mobilization, preparing the body for action. The other supports rest, recovery, and internal maintenance. In everyday life, these two branches work together continuously, shifting dominance depending on conditions. Silence gently tips this balance. As auditory stimulation decreases, the body receives fewer signals that demand immediate response, allowing the system associated with rest to become more active. This shift does not happen instantly. When sound first fades, the body may remain slightly alert, listening for what might come next. Over time, if the quiet continues without disruption, the nervous system adapts. Heart rate often slows subtly. Breathing patterns tend to deepen and become more regular without conscious control. Muscle tone softens in small, almost imperceptible ways. These changes reflect a gradual release from vigilance rather than a forced relaxation. Silence also affects how sensory information is prioritized. In louder environments, the nervous system must allocate resources to processing sound, maintaining readiness for unexpected input. When sound levels drop, fewer resources are required for auditory monitoring. This allows the nervous system to redirect attention inward, supporting processes related to digestion, immune function, and tissue repair. Silence creates a low-demand environment, reducing the overall load placed on the system. From a biological standpoint, this response is deeply rooted in survival history. For much of human evolution, quiet environments often indicated relative safety. Continuous noise, especially irregular or sudden sounds, could signal danger or activity requiring attention. The body learned to associate sustained quiet with opportunities for rest and recovery. Even today, the nervous system responds to silence in much the same way, regardless of modern context. Silence also reduces sensory conflict. When multiple stimuli compete for attention, the nervous system must resolve which signals matter most. This constant filtering can contribute to subtle stress over time. In quieter settings, fewer signals compete for priority. The nervous system can maintain stability with less effort, allowing internal rhythms to reassert themselves naturally. Studies examining physiological markers have shown that periods of quiet are associated with reduced levels of stress-related hormones and increased activity in systems linked to restoration. These changes do not require meditation, intention, or effort. They occur simply because the environment places fewer demands on sensory processing. Silence acts as a passive support, not an active intervention. Importantly, silence does not remove stimulation entirely. The body continues to receive input from within, such as the rhythm of breathing, the movement of blood, and subtle shifts in posture. In quieter conditions, these internal signals become more noticeable, not because they increase, but because external noise no longer masks them. This inward awareness is a natural consequence of reduced outward demand. The nervous system responds to these conditions with efficiency. Rather than remaining on high alert, it settles into a state that balances awareness with ease. This state is not unconsciousness or shutdown. It is a regulated, low arousal mode that supports recovery, while remaining responsive to the environment if needed. You do not need to guide or manage this response. The nervous system recognizes silence instinctively and adjusts on its own timeline. As quiet continues, the body follows, easing away from constant readiness and toward a steadier internal rhythm. Silence becomes a biological signal of permission, allowing the nervous system to release tension and support the gradual settling of the mind into calm. In everyday life, attention is rarely at rest. The human mind is constantly allocating focus, shifting between tasks, monitoring the environment, and responding to signals that arrive through the senses. Sound plays a particularly strong role in this process because it is difficult to ignore completely. Even when we believe we are tuning noise out, the brain continues to evaluate it, deciding whether it is familiar, relevant, or potentially important. This ongoing evaluation creates mental load, a quiet demand on attention that often goes unnoticed. Silence changes this dynamic in a measurable way. When sound diminishes, the number of external signals competing for attention decreases. The brain no longer needs to maintain the same level of vigilance toward the environment, and attention begins to reorganize itself. This does not mean focus disappears. Instead, attention becomes less fragmented, no longer pulled in multiple directions by overlapping auditory input. Neuroscience research shows that attention operates through networks that constantly balance external focus and internal awareness. In noisy conditions, external attention networks remain active, scanning for changes and prioritizing sound-based information. Silence allows these networks to reduce their activity. As they do, the brain shifts toward a more internally oriented mode, where attention is not anchored to specific external cues. This shift reduces cognitive effort. Processing sound requires resources, even when the sound is repetitive or familiar. Each noise must still be identified, categorized, and filtered. In quiet environments, this filtering work decreases. The brain uses less energy to maintain attention, freeing resources for other processes such as memory integration, emotional regulation, and spontaneous thought. Silence also affects how long attention can remain stable. In environments filled with sound, attention is frequently interrupted, even if only briefly. These micro-interruptions accumulate, contributing to mental fatigue over time. In quieter settings, attention is less likely to be pulled away unexpectedly. This allows focus, whether directed outward or inward, to settle more deeply and remain steady for longer periods. From a biological perspective, this stability is restorative. The brain is not designed to operate in a constant state of interruption. Periods of reduced stimulation give attention systems an opportunity to recalibrate, restoring balance between effort and ease. Silence provides this opportunity without requiring deliberate control or training. Another important aspect of silence is its effect on decision-making demand. Sound often carries information that prompts evaluation. Is this noise important? Should it be ignored? Does it require action? Each of these questions, even when answered unconsciously, adds to mental workload. Silence removes many of these prompts altogether. With fewer signals to evaluate, the mind experiences a sense of relief, not because it is doing less thinking, but because it is being asked fewer questions. Silence also allows attention to broaden. Without constant external demands, awareness can expand rather than narrow. Instead of locking onto specific stimuli, the mind may drift gently, moving between thoughts, sensations, and memories without urgency. This state is associated with reduced stress and increased feelings of ease, not because of inactivity, but because attention is no longer constrained by immediate demands. Importantly, this does not mean silence eliminates all focus. The brain remains capable of responding quickly if needed. Attention is not shut down, only relaxed. This relaxed readiness is biologically efficient. It conserves energy while preserving the ability to engage when necessary. The effects of silence on attention also help explain why quiet environments often feel mentally spacious. With fewer interruptions and less background processing, thoughts feel less crowded. The mind has room to breathe, not because it is being guided, but because it is no longer being pulled apart by competing signals. You do not need to concentrate on silence for these changes to occur. Attention adjusts automatically in response to the environment. As sound recedes, mental load lightens, and the mind settles into a more balanced state. Silence becomes not a void, but a condition in which attention can rest without losing its clarity, supporting calm awareness and easing the mind gently toward deeper stillness. When the environment grows quiet, the brain gains access to processes that are difficult to sustain amid constant sound. One of the most important of these processes involves memory. Memory is not formed only in moments of activity or attention. Much of it is shaped afterward, during periods when the brain is free from heavy sensory demands. Silence provides a biological setting in which this quieter work can take place. Throughout the day, the brain continuously receives information. Sounds, images, words, and experiences are encoded rapidly, often without conscious awareness. These initial recordings are fragile. For memories to become stable, they must be processed further, strengthened, and integrated with existing knowledge. This consolidation does not happen well when the brain is busy responding to ongoing stimulation. Silence reduces interference, allowing this internal organization to proceed more smoothly. Neuroscientific studies have shown that reduced sensory input supports activity in brain regions associated with memory consolidation, particularly the hippocampus. This region plays a central role in stabilizing new information and linking it to long-term storage. In quiet conditions, neural signaling within these networks becomes more coordinated, helping experiences move from short-term holding into more durable memory structures. Silence also supports the replay of neural patterns. After experiences occur, the brain often reactivates similar patterns of activity, strengthening connections between neurons. This replay is subtle and internal. It does not require awareness and is easily disrupted by external demands. When sound levels are low, these reactivation processes are more likely to unfold uninterrupted, giving the brain time to refine what it has already recorded. Importantly, this does not mean silence forces memory formation. It simply removes obstacles. In noisy environments, the brain must constantly decide which sounds to monitor and which to ignore. This ongoing filtering competes with internal processing. Silence reduces the need for that filtering, freeing resources that can be redirected toward memory-related activity. Silence also affects emotional memory. Experiences are not stored as neutral data. They are colored by emotional context, which influences how strongly they are remembered. Quiet environments tend to reduce emotional reactivity, allowing memories to be integrated with less distortion. This can support a more balanced emotional narrative, where experiences are remembered without being amplified by stress or urgency. From a biological perspective, this relationship makes sense. Throughout evolutionary history, quiet periods often followed activity. After foraging, movement, or social interaction, quieter moments allowed the brain to process what had just occurred. Silence became associated with integration rather than acquisition, supporting learning without requiring constant engagement. Even brief moments of quiet can have measurable effects. Research suggests that short periods of silence can support neural growth and connectivity in regions involved in learning and memory. These changes are subtle and cumulative, building over time rather than producing immediate, noticeable effects. Silence works gradually, reinforcing stability rather than creating sudden shifts. The human mind does not need to direct this process. Memory consolidation happens automatically when conditions allow it. Silence creates those conditions by reducing competition for neural resources. The brain does the rest on its own, sorting, strengthening, and integrating without instruction. Silence also changes how memories feel subjectively. In quiet moments, recall may feel clearer and less fragmented. Thoughts arise with fewer interruptions, allowing memory to surface gently rather than being forced. This does not mean silence improves recall on demand, but it supports a mental environment where remembering feels easier and less effortful. It is important to note that silence does not erase or suppress memory. It supports organization, not removal. The brain remains selective, keeping what matters and allowing less relevant details to fade. Silence simply gives that selection process room to operate without constant external input. You do not need to use silence intentionally for memory to benefit. Whenever sound decreases naturally, the brain responds. As quiet continues, memory systems shift into a mode of gentle refinement, strengthening connections and smoothing transitions between experiences. Silence becomes a biological pause, offering the brain time to settle what it has gathered, allowing memory to form calmly and securely beneath awareness, without urgency or effort. Beyond attention and memory, silence plays a subtle role in the brain's ability to repair and maintain itself. Neural tissue is constantly active, adapting and reshaping in response to experience. This ongoing activity requires periods of lower stimulation to remain balanced. Silence provides a biological window in which restorative processes can unfold with less interference. Neurons communicate through electrical and chemical signals, and this communication generates metabolic byproducts that must be cleared efficiently. During periods of reduced sensory input, including quiet environments, the brain can shift resources toward maintenance rather than response. This does not mean the brain shuts down. Instead, it reallocates effort, supporting processes that preserve neural health over time. One system that becomes especially relevant during quiet states is the brain's waste clearance network. This system helps remove excess proteins and metabolic byproducts that accumulate during waking activity. While it is most active during sleep, research suggests that low stimulation conditions, including silence, may support its function by reducing competing neural demands. Quiet creates favorable conditions for internal housekeeping. Silence also influences neuroplasticity, the brain's ability to change and adapt. Learning and experience strengthen some neural pathways while weakening others. For these adjustments to stabilize, the brain needs time without constant input. Silence offers that time. With fewer external signals to process, neural circuits can reinforce useful connections and allow less relevant ones to soften. Importantly, this process does not feel dramatic or noticeable. Neural repair is gradual, occurring at microscopic scales over long periods. Silence supports it indirectly by reducing the overall load placed on the system. Just as muscles benefit from rest between exertion, neural tissue benefits from reduced stimulation between periods of activity. The balance between excitation and inhibition in the brain also stabilizes during quiet conditions. Continuous sound keeps excitatory pathways engaged, maintaining readiness. Silence allows inhibitory processes to regain influence, preventing overstimulation and supporting long-term stability. This balance is essential for preventing fatigue and maintaining clear, flexible neural function. From a biological perspective, this makes silence a form of passive support rather than active treatment. Nothing needs to be added or removed. The environment simply becomes less demanding, and the brain responds by shifting toward maintenance and repair. This response is automatic and does not require intention or awareness. Silence also reduces stress-related neural signaling. Chronic exposure to noise has been linked to increased activation of stress pathways, even when the noise is not consciously perceived as disturbing. Quiet environments reduce this background activation, allowing stress-related systems to downshift. Over time, this reduction supports healthier neural regulation. The human mind does not need to seek silence deliberately for these benefits to occur. Whenever sound diminishes naturally, the brain responds. These responses accumulate quietly, contributing to resilience rather than producing immediate effects. Silence works in the background, supporting the brain in ways that are felt more as ease than as change. As quiet continues, neural activity settles into a more sustainable rhythm. Repair and regulation proceed without interruption, guided by biological priorities rather than external demands. Silence becomes part of the brain's natural maintenance cycle, offering space for recovery without asking for effort, attention, or control, gently supporting the mind as it drifts toward deeper calm. Emotional states are shaped not only by thoughts and experiences, but also by the sensory environment in which those experiences occur. Sound plays a powerful role in emotional regulation because it continuously signals context. Sudden or unpredictable noises can increase emotional reactivity, while steady or quiet environments tend to support balance. Silence, in particular, creates conditions that allow emotional systems to stabilize without effort or instruction. The brain areas involved in emotional processing are closely linked to sensory input. When sound is present, especially if it is complex or irregular, emotional centers remain alert, ready to respond. Silence reduces this demand. With fewer external signals to evaluate, emotional processing slows, becoming less reactive and more regulated. This does not suppress emotion. It allows emotional responses to settle naturally. Silence also affects the way emotions are integrated over time. Experiences often leave emotional traces that linger after events have passed. In noisy environments, these traces may be amplified or interrupted repeatedly by external input. Quiet environments allow emotional information to be processed more smoothly, reducing intensity without erasing meaning. Silence gives emotions space to resolve rather than compete. From a biological perspective, this effect is tied to stress response systems. Continuous sound can keep stress-related pathways mildly activated, even when the sound is familiar or ignored. Silence reduces this background activation, allowing the body's regulatory systems to recalibrate. Hormonal signals linked to stress gradually decrease, while systems associated with calm and recovery regain influence. Silence also supports emotional clarity. When fewer sensory inputs demand attention, internal signals become easier to interpret. Feelings may feel simpler or less overwhelming, not because they are reduced, but because they are no longer layered beneath constant stimulation. This clarity can make emotional states feel more manageable, even without conscious reflection. Importantly, silence does not force emotional change. It does not instruct the brain to feel calm or safe. It simply removes pressure. The emotional system responds by finding its own balance point, guided by biology rather than effort. This makes silence particularly supportive for emotional regulation because it does not require control or intention. Over time, repeated exposure to quiet environments can reinforce this regulatory pattern. The emotional system learns that low stimulation conditions are stable and predictable. This learning does not occur consciously, but through repeated biological responses. Silence becomes associated with safety and resolution, shaping how emotions respond when sound recedes. Even brief moments of quiet can contribute to this effect. Pauses between sounds, gentle reductions in noise, or quiet evenings all provide opportunities for emotional systems to settle. These moments accumulate, supporting resilience rather than producing immediate change. Silence works gradually, strengthening balance rather than triggering release. The human mind does not need to focus on emotions for this process to unfold. Emotional regulation adjusts automatically in response to the environment. As sound fades, reactivity softens, and emotional tone becomes steadier. Silence offers a background of stability, allowing feelings to exist without being pushed or pulled. As quiet continues, emotional systems remain responsive but less strained. The environment asks less, and the body responds by offering more internal balance. Silence becomes not a void, but a steady presence, supporting emotional regulation gently and consistently, allowing the mind to settle further into calm, without effort or expectation. When sound recedes, the body's sensory systems begin to rebalance themselves. Hearing is only one part of a broader network of senses that work together to interpret the environment. In noisy conditions, auditory input often dominates, demanding priority because sound can signal movement, distance, or change beyond the field of vision. Silence reduces this dominance, allowing other senses to settle into a more even relationship. The brain constantly integrates sensory information, deciding which signals matter most at any given moment. When sound is present, especially if it is unpredictable or layered, sensory resources are directed toward monitoring it. When the environment becomes quiet, that demand decreases. Vision, touch, and internal bodily sensations are no longer competing with continuous auditory input. This shift allows sensory processing to become more balanced and less strained. One noticeable effect of silence is an increased awareness of internal sensation. Subtle signals such as breathing rhythm, heartbeat, and changes in posture become easier to notice, not because they grow stronger, but because external noise no longer masks them. This internal sensory awareness is part of the body's regulatory system, providing feedback that supports balance and calm. Silence allows this feedback to surface naturally. Silence also affects how the brain filters sensory information. In complex environments, sensory filtering must work constantly to prevent overload. This filtering requires effort at a neural level. In quieter conditions, fewer signals need to be filtered out, reducing overall sensory demand. The brain can process what remains more efficiently without needing to prioritize aggressively. This rebalancing supports physical comfort as well. Muscle tension is often maintained in response to environmental demands, including sound. Sudden noises can trigger reflexive tightening, even when consciously ignored. As silence continues, these reflexive responses diminish. Muscles are allowed to release small amounts of tension, contributing to a sense of ease that spreads gradually through the body. From a biological perspective, this sensory shift is protective. The nervous system is designed to respond quickly when necessary, but not to remain in a constant state of readiness. Silence signals that rapid response is unlikely to be required. As a result, sensory systems are permitted to downshift, conserving energy and reducing strain. Silence also changes how the environment is perceived spatially. Without sound defining distance or movement, space can feel larger and more open. This effect is not psychological alone. It reflects changes in how sensory information is weighted and integrated. The absence of auditory cues allows visual and proprioceptive signals to shape perception more gently. Importantly, silence does not dull the senses. It refines them. Sensory systems remain fully capable of responding if needed. They simply operate in a lower demand mode, ready but not tense. This balance supports long-term sensory health, preventing fatigue that can arise from constant stimulation. The human mind does not need to manage this rebalancing. Sensory systems adjust automatically based on environmental input. When sound diminishes, the body follows, redistributing attention across senses in a way that feels calm rather than effortful. As quiet continues, sensory experience becomes simpler and more cohesive. Signals align rather than compete, and perception feels less crowded. Silence creates a sensory environment where balance can reassert itself, allowing the body and mind to settle together, supported by the absence of excess demand, gently preparing for deeper rest. When the environment grows quiet, the way time is experienced often begins to change. This shift does not come from clocks slowing down or events stopping, but from changes in how the human mind processes information. Time perception is closely tied to sensory input. The more signals the brain must track, the fuller time feels. Silence reduces that flow of information, allowing time to feel less segmented and more continuous. In noisy environments, the brain is constantly marking moments. Each sound creates a reference point, dividing experience into smaller units. These divisions give time a busy, fragmented quality. When sound fades, fewer markers are present. The brain no longer needs to register frequent changes, and time begins to feel smoother, less broken into parts. Minutes may seem to stretch, not because they are longer, but because fewer events compete for attention within them. Neuroscience suggests that the brain estimates time partly by monitoring internal and external changes. When many changes occur, time feels dense. When fewer changes are detected, time feels spacious. Silence reduces external change dramatically. Without frequent auditory input, the brain registers fewer transitions, and subjective time expands gently, creating a sense of openness rather than pressure. This expansion does not mean boredom or restlessness. Instead, it often feels like relief. Without constant cues signaling progression, the mind is no longer pushed forward. Attention settles into the present moment without effort. Time becomes something to exist within rather than something to manage or track. Silence also influences the body's internal rhythms, which contribute to time perception. Heart rate, breathing, and neural oscillations often slow slightly in quiet environments. These rhythms help structure how the brain senses duration. When they become steadier and less reactive, time feels less urgent and more fluid. The body and mind begin to agree on a slower pace. From a biological perspective, this shift makes sense. Periods of quiet historically followed activity. After movement or interaction, reduced stimulation allowed the brain to integrate experience rather than seek new input. Time during these periods was not meant for action, but for settling. Silence still carries this signal, encouraging the brain to move away from forward momentum. Silence can also reduce the pressure to anticipate. Sound often signals what might happen next. Footsteps approach, voices rise, machines activate. In silence, there is less information suggesting immediate change. Without this anticipatory demand, the brain relaxes its grip on the future. Attention remains grounded in the present, and time feels less directional. Importantly, this effect does not require awareness. You do not need to notice time slowing for it to feel different. The change occurs automatically as sensory input decreases. The brain adjusts its internal pacing to match the environment, and perception follows. This altered sense of time supports rest. When time feels less crowded, there is less urgency to think ahead or recall what just happened. Thoughts may drift more freely without being pulled along by a sense of schedule or sequence. Silence allows experience to unfold without being measured moment by moment. Even brief periods of quiet can trigger this shift. Pauses between sounds, quiet rooms, or gentle evenings offer opportunities for time perception to soften. These moments accumulate, teaching the brain that not every moment must be filled or tracked. As silence continues, time becomes less of a structure and more of a background. The day no longer feels like a series of steps to move through, but like a steady space to rest within. Silence reshapes time not by changing its passage, but by changing how it is felt, allowing the mind to settle into a slower, calmer rhythm, where moments are not counted, but simply experienced. The body's stress response is designed to be fast, efficient, and protective. It activates when the environment signals uncertainty or demand, preparing the body to respond. Sound plays a powerful role in triggering this response because it can signal sudden change or potential threat, even when nothing is visible. Silence alters this signaling, changing how the body interprets its surroundings at a fundamental level. In environments filled with sound, the stress response often remains lightly engaged. Even familiar or ignored noise requires monitoring. The body stays prepared, maintaining a baseline level of alertness that consumes energy over time. Silence reduces the number of cues that might demand reaction. With fewer signals suggesting urgency, the stress response begins to ease without conscious effort. This easing is reflected in physiological changes. Stress-related hormones gradually decrease when auditory stimulation is reduced. Heart rate variability often improves, indicating better balance between activation and recovery systems. Muscle tension softens subtly as reflexive readiness diminishes. These changes do not happen all at once. They unfold gradually as the body confirms that quiet is stable and uninterrupted. Silence also affects how quickly the stress response is triggered. In quieter environments, the threshold for activation often increases. The body becomes less reactive to minor stimuli because it is no longer primed by constant noise. This does not make the system sluggish. It makes it more selective, responding appropriately rather than reflexively. From a biological perspective, this selectivity is efficient. The stress response is valuable when needed, but costly when overused. Silence helps recalibrate sensitivity, ensuring that activation occurs for meaningful reasons rather than background stimulation. Over time, this recalibration supports resilience, reducing wear on regulatory systems. Silence also supports recovery after stress has already occurred. Following periods of heightened activation, the body needs time to return to baseline. Noise can prolong recovery by maintaining stimulation. Quiet environments allow stress-related systems to stand down fully, completing the recovery cycle rather than leaving it partially engaged. Importantly, silence does not require stillness or isolation to have this effect. Even quiet spaces with gentle movement or soft background presence can reduce stress load as long as sound remains predictable and minimal. The key factor is the absence of unpredictable auditory demand. The human mind does not need to direct this process. The body responds automatically to changes in sensory input. As sound diminishes, the stress response adjusts, guided by physiology rather than thought. This adjustment supports a state of calm readiness rather than constant vigilance. Over time, repeated exposure to quiet conditions reinforces this pattern. The body learns that silence is safe, predictable, and supportive of recovery. This learning shapes how stress systems respond, even when sound returns, improving regulation overall. As silence continues, the body settles into a steadier internal state. Stress responses remain available but inactive, ready without being engaged. Silence becomes a biological signal of safety, allowing the body to rest from constant alertness and easing the mind further into calm, without effort or instruction. Inside the brain, activity unfolds in rhythmic patterns. These rhythms, often called brain waves, reflect how groups of neurons communicate and coordinate. They shift continuously based on what the brain is doing and what the environment demands. Sound has a strong influence on these rhythms because it requires constant processing. When silence emerges, the brain's rhythmic activity begins to change in subtle, measurable ways. In louder or more complex sound environments, faster brain rhythms tend to dominate. These rhythms support alertness, analysis, and rapid response. They are useful for navigating busy situations, but they require sustained energy. Silence reduces the need for this high-frequency activity. With fewer auditory signals to decode, the brain gradually shifts towards slower, more stable rhythms. Slower brain rhythms are associated with rest, integration, and internal awareness. They support processes such as emotional regulation, memory consolidation, and the transition towards sleep. Silence does not force these rhythms to appear. Instead, it removes the stimulation that keeps faster rhythms active. The brain naturally adjusts, guided by efficiency rather than instruction. This shift in rhythm is not uniform across the brain. Some regions quiet more quickly than others. Auditory processing areas respond first, followed by networks involved in attention and vigilance. Over time, coordination between regions becomes smoother. Communication feels less urgent and more synchronized, supporting a sense of internal coherence. Silence also stabilizes rhythmic activity. In noisy environments, brain rhythms can become fragmented, constantly resetting in response to changing input. Quiet conditions allow rhythms to maintain continuity. This stability supports mental clarity and reduces cognitive strain, even when awareness remains present. From a biological perspective, rhythmic stability is restorative. Neurons operate more efficiently when communication patterns are consistent rather than constantly disrupted. Silence creates conditions where this consistency can emerge naturally. The brain does not need to work harder. It works more smoothly. These changes often go unnoticed subjectively. You may not feel your brain rhythm slowing or stabilizing. Instead, you might notice a general sense of ease or softness in awareness. This feeling reflects underlying neural coordination rather than conscious relaxation. Silence also supports transitions between states of consciousness. The same rhythmic shifts that occur in quiet environments are involved in the movement from wakefulness toward drowsiness. Silence prepares the brain for these transitions by reducing competing signals and allowing slower rhythms to gain influence gradually. Importantly, silence does not suppress thought. Thoughts may continue to arise, but they often do so with less urgency and less fragmentation. Brain rhythms support this by providing a steadier backdrop for mental activity. Thinking becomes less driven and more fluid. The human mind does not need to guide these changes. Brain rhythms respond automatically to sensory conditions. When sound recedes, rhythmic activity adjusts, seeking balance rather than stimulation. This adjustment supports calm awareness and prepares the brain for deeper rest without forcing any particular outcome. As quiet continues, rhythmic patterns settle into a sustainable pace. Communication between neurons becomes more efficient, less hurried, and more coordinated. Silence offers the brain a rhythmic environment where it can regulate itself gently, easing the mind toward a state of quiet continuity, supported by stable, calming patterns of activity. Silence does not act directly on the body in the way medicine or movement does. Yet it creates conditions that support healing at a fundamental level. Healing in the body depends on balance, energy availability, and uninterrupted internal communication. When sound is reduced, the body experiences fewer external demands, allowing more resources to be directed toward maintenance and repair. The body is constantly renewing itself. Cells divide, tissues repair microscopic damage, and systems recalibrate their internal signals. These processes occur continuously, but they function most efficiently when the body is not preparing for immediate action. Silence contributes to this efficiency by lowering overall arousal. With fewer sensory signals demanding response, the body can shift attention inward, supporting recovery rather than readiness. One way silence supports healing is through its effect on circulation and oxygen use. In quieter environments, breathing often becomes slower and deeper without conscious effort. This improves oxygen exchange and supports the delivery of nutrients throughout the body. Blood flow becomes more evenly distributed, favoring internal organs and tissues involved in repair rather than muscles prepared for movement. Silence also influences immune activity. The immune system is sensitive to stress signals, which can be amplified by constant noise. Quiet environments reduce background stress signaling, allowing immune responses to remain balanced rather than overactivated. This balance supports the body's ability to respond appropriately to challenges while maintaining routine maintenance tasks. From a neurological perspective, silence supports communication between the brain and the rest of the body. When the brain is less occupied with processing sound, it can regulate bodily systems more smoothly. Signals related to digestion, tissue repair, and hormone release become clearer and more consistent. Silence does not create these signals. It reduces interference so they can be transmitted efficiently. Healing also depends on timing. Many restorative processes occur during periods of rest or low stimulation. Silence helps create these periods naturally. The body recognizes quiet as a signal that activity has decreased, allowing it to transition into maintenance mode. This transition does not require intention. It is built into the body's regulatory systems. Importantly, silence does not accelerate healing in dramatic ways. Its influence is subtle and cumulative. By repeatedly reducing sensory demand, Silence supports an environment in which healing processes can operate without unnecessary interruption. Over time, this contributes to resilience and balance rather than rapid change. Silence also reduces muscular strain. Without constant auditory cues signaling potential action, muscles are less likely to remain partially engaged. This reduction in baseline tension supports circulation and reduces fatigue, indirectly aiding tissue recovery. Small changes like these accumulate quietly, supporting overall physical ease. The human mind does not need to focus on healing for these benefits to occur. The body responds automatically to its environment. When sound diminishes, internal systems adjust, favoring restoration over response. Silence becomes a passive partner in healing, not by directing the body, but by allowing it to do what it is already designed to do. As quiet continues, the body settles into a steadier internal rhythm. Repair processes proceed without urgency, guided by biological priorities rather than external demand. Silence supports healing not by acting as a cure, but by creating space, allowing the body's natural restorative systems to operate calmly and continuously, easing the mind further toward rest and balance. At a chemical level, the body responds to silence in ways that support balance rather than stimulation. Hormones and neurotransmitters act as messengers, carrying information between the brain and the rest of the body. Their levels shift constantly in response to the environment. Sound, especially when it is unpredictable or persistent, can influence these chemical signals. Silence changes that influence by reducing the triggers that keep certain systems activated. In louder environments, chemicals associated with alertness and readiness tend to remain elevated. These substances help the body stay responsive, but maintaining them over long periods requires energy and can contribute to fatigue. When sound diminishes, the signals that sustain this chemical state weaken. The body begins to favor chemicals linked to calm regulation and recovery. Silence supports the release and balance of neurotransmitters involved in mood stability and emotional regulation. With fewer external demands, neural communication becomes less reactive. Chemical signaling within the brain becomes steadier, reducing sharp fluctuations. This stability does not dull awareness. It supports a smoother internal environment where emotional tone is less likely to swing rapidly. Hormonal systems also respond to quiet conditions. Stress-related hormones gradually decrease when auditory stimulation is low and predictable. At the same time, systems that support restoration and equilibrium gain influence. These changes occur gradually, reflecting the body's preference for confirmation rather than sudden shifts. Silence allows the body to verify that conditions are stable before fully adjusting. The chemistry of calm also supports sleep-related transitions. Many of the chemical changes that prepare the body for sleep are incompatible with constant stimulation. Silence removes barriers to these transitions by reducing signals that would otherwise maintain alertness. The body does not need to be instructed to prepare for rest. It follows chemical pathways shaped by the absence of demand. Importantly, silence does not force chemical changes. It creates favorable conditions. Just as the body regulates temperature more easily in a stable environment, it regulates chemistry more smoothly in quiet surroundings. The absence of noise allows regulatory systems to operate without interruption, maintaining balance rather than reacting continuously. Silence also influences how long these chemical states persist. In noisy environments, calm-related signaling may be interrupted repeatedly, preventing full stabilization. Quiet allows these signals to remain active longer, reinforcing a sense of internal ease. Over time, this persistence supports resilience, making it easier for the body to return to balance after stimulation. The human mind does not need to be aware of these processes. Chemical regulation happens beneath conscious thought. Silence works quietly at this level, shaping internal conditions without requiring attention. The result is often felt not as a specific change, but as a general sense of steadiness. As quiet continues, chemical systems settle into a rhythm that favors maintenance and calm. Signals align rather than compete, supporting coherence throughout the body. Silence becomes a chemical environment as much as a sensory one, offering the body space to regulate itself gently, allowing the mind to drift further into a state of calm continuity, without effort or direction. Silence influences not only how the body and brain function, but also how the sense of self is experienced. The feeling of being you is not fixed or separate from the environment. It is shaped moment by moment by attention, sensation, and internal narrative. Sound plays a role in maintaining that narrative by constantly anchoring awareness to the outside world. When sound fades, the structure supporting that narrative softens. In busy auditory environments, the mind is often oriented outward. Sounds signal activity, presence, and interaction, reinforcing a sense of separation between the listener and the environment. Silence reduces these signals. With fewer external anchors, attention naturally shifts inward, and the boundary between observer and surroundings becomes less pronounced. Neuroscience research suggests that the sense of self is maintained by networks that integrate sensory input with memory and expectation. When sensory input decreases, these networks become less rigid. Silence allows them to loosen their grip, creating a more fluid experience of identity. This does not eliminate the sense of self. It makes it quieter and less defined. In silent conditions, internal experience often becomes more spacious. Thoughts may arise more slowly, with less urgency to define or explain them. Without constant external cues, the narrative voice of the mind has less material to work with. As a result, the sense of doing gives way to a sense of being, even without intention. This shift is not philosophical or abstract. It reflects changes in how attention is allocated. When sound is present, attention is frequently pulled outward. Silence allows attention to rest inward, supporting awareness without constant evaluation. The self becomes less something to manage and more something that simply exists within experience. From a biological perspective, this inward settling supports regulation. The nervous system responds to silence by reducing vigilance, and this reduction carries into how identity is experienced. When there is less need to monitor the environment, there is less need to maintain a tightly defined sense of self. The experience becomes softer, more open. Silence also reduces comparison. Sound often carries social information, voices, movement, activity. In quiet environments, these cues diminish. Without them, the mind has fewer reference points for comparison or judgment. The sense of self becomes less reactive, less shaped by external context. Importantly, Silence does not require introspection to produce these effects. The shift happens naturally as sensory demand decreases. You do not need to think about identity or awareness. The environment does the work by offering fewer signals to organize around. As quiet continues, the sense of self may feel less central and less demanding. Awareness expands without needing to attach to specific thoughts or roles. This does not feel like loss. It feels like ease, as though something that was being held tightly has been allowed to rest. Silence supports this easing by removing the constant reinforcement of external identity cues. The self remains present, but quieter, less insistent. In this softened state, awareness feels more continuous and less fragmented, allowing the mind to rest within experience rather than narrate it. As the environment stays quiet, this gentler sense of self persists. Nothing needs to be defined or defended. Silence provides a setting where identity can loosen without disappearing, supporting a calm, spacious awareness that feels steady and unforced, gently guiding the mind toward deeper rest and stillness. Silence has long been associated with creativity, not because it produces ideas directly, but because it removes the conditions that prevent them from forming. Creative thought depends on connection, association, and the ability for ideas to move freely without interruption. Sound, especially when constant or unpredictable, can fragment this process. Silence allows it to unfold more smoothly. When the environment is quiet, the brain is less occupied with responding to external signals. Attention becomes less constrained, and thought is no longer pulled toward immediate stimuli. This creates space for ideas to combine in unexpected ways. Creativity often arises not from effort, but from relaxed exploration, and silence supports this state by lowering demand rather than increasing focus. Neuroscience research suggests that creative thinking is supported by networks that operate best when external pressure is reduced. These networks are active during rest, daydreaming, and gentle internal wandering. Silence encourages this mode by allowing attention to drift without being redirected by sound. The mind is free to explore without needing to respond. Silence also supports incubation, a key phase of creativity where ideas develop beneath awareness. During incubation, the brain continues working on problems without conscious direction. External stimulation can disrupt this process by pulling attention outward. Quiet environments protect incubation by reducing interference, allowing ideas to mature naturally. Importantly, silence does not force creativity or guarantee inspiration. It simply creates conditions where creative processes are less likely to be interrupted. Just as a calm environment supports sleep without causing it, silence supports creativity without demanding output. The brain responds by becoming more flexible and open. From a biological perspective, this flexibility reflects reduced cognitive control. In quiet conditions, the brain loosens rigid patterns of thinking, allowing alternative pathways to be explored. This shift is subtle and often felt as ease rather than insight. Creativity emerges gently, not through pressure, but through permission. Silence also reduces self-monitoring. Sound often carries social cues that trigger evaluation and judgment. In quiet environments, these cues diminish, and the inner critic loses some of its influence. Thoughts can arise without being immediately assessed, increasing the likelihood of novel combinations and perspectives. The human mind does not need to seek ideas actively for this effect to occur. Creative processes adjust automatically to the environment. When sound recedes, mental space opens and ideas have room to move without collision. Silence becomes a neutral ground where thought can reorganize itself. Over time, repeated exposure to quiet conditions strengthens this relationship. The brain learns that silence is a place of exploration rather than demand. This learning supports creativity not only during quiet moments, but also afterward, by reinforcing flexibility in thinking. As silence continues, creative thought flows more freely, without urgency or expectation. Ideas appear and fade, without pressure to be captured or completed. Silence offers a supportive backdrop for creativity, not by producing content, but by removing obstacles, allowing the mind to wander, connect, and settle into a gentle rhythm of possibility and calm. As silence continues, the body and brain begin to move toward deeper states of rest without needing instruction. Deep rest is not the absence of awareness, but a condition where internal systems operate with minimal resistance. Sound, when present, keeps parts of the brain lightly engaged, even if it is familiar or ignored. Silence removes this engagement gradually, allowing rest to deepen naturally. In quiet environments, the body's baseline level of arousal decreases. This does not mean the body becomes inactive. Instead, it shifts into a mode where energy is conserved and distributed efficiently. Breathing often becomes slower and more rhythmic. Heart rate steadies. The nervous system reduces unnecessary signaling, creating a physiological foundation that supports rest at multiple levels. The brain responds similarly. Without constant auditory input, networks associated with monitoring and response reduce their activity. This allows slower, more restorative patterns of neural communication to take hold. These patterns are closely linked to the early stages of sleep and deep relaxation. Silence does not cause sleep directly, but it prepares the brain by aligning its rhythms with rest rather than alertness. Deep rest also depends on predictability. Sudden sounds can disrupt the settling process by triggering reflexive responses. Silence provides consistency. When the environment remains quiet, the brain learns that it does not need to remain on standby. Over time, this confirmation allows rest-related processes to proceed more fully, without interruption. Silence supports deep rest by reducing sensory load. With fewer signals to process, the brain can focus on internal regulation. This supports the release of physical tension and the easing of mental effort. Rest becomes something the body enters rather than something it must achieve. From a biological perspective, deep rest is essential for long-term health. Many restorative processes, including cellular repair and immune regulation, are more effective when the body is not expending energy on vigilance. Silence helps create the conditions necessary for these processes by signaling safety and stability. Importantly, deep rest does not require complete stillness. The body may shift position, and thoughts may continue to arise. What matters is the absence of demand. Silence removes pressure, allowing rest to deepen even amid gentle movement or drifting awareness. The human mind does not need to attempt relaxation for this to occur. Rest emerges naturally as stimulation decreases. Silence acts as a guide, not by directing attention, but by removing obstacles. The mind follows the body, settling into a quieter, steadier state. As silence persists, rest becomes more complete. Awareness remains present but unburdened. The environment asks nothing, and the body responds by letting go of effort. Silence supports this release gently and consistently, allowing deep rest to unfold at its own pace, carrying the mind towards stillness without force or expectation. As the environment remains quiet, the body and brain naturally begin to approach the threshold of sleep. Sleep onset is not a switch that flips, but a gradual transition shaped by sensory input, internal rhythms, and biological readiness. Silence plays a supporting role in this transition by removing one of the primary signals that keeps the brain externally oriented. Sound is one of the last senses to disengage before sleep. Even with closed eyes and stillness, the brain continues to monitor auditory input for relevance or threat. Silence reduces this monitoring requirement. With fewer sounds to evaluate, the brain is no longer compelled to remain outwardly attentive. Attention softens, and awareness begins to drift inward. Neuroscience shows that as sleep approaches, brain activity gradually shifts away from fast, alert patterns towards slower, more synchronized rhythms. Silence supports this shift by reducing sensory interruptions that would otherwise reinforce wakefulness. The brain does not need to suppress alertness actively. It simply stops being stimulated into maintaining it. The body responds in parallel. As auditory demand decreases, the nervous system continues its movement toward parasympathetic dominance. Breathing becomes more regular. Muscle tone lowers further. The body confirms, moment by moment, that no immediate response is required. This confirmation is essential for sleep onset, as uncertainty can delay the transition. Silence also reduces anticipatory processing. Sound often carries information about what might happen next. In its absence, the brain has fewer reasons to project forward. Thoughts lose urgency, and the sense of waiting diminishes. This lack of anticipation allows consciousness to loosen its grip, drifting without direction. Importantly, silence does not need to be perfect. Even consistent, low-level quiet is enough to support sleep onset. What matters is predictability. When the auditory environment remains stable and non-demanding, the brain learns that it can disengage safely. Sleep onset is also supported by chemical changes that unfold more easily in quiet conditions. Signals associated with alertness gradually decrease, while those associated with rest gain influence. Silence does not trigger these changes directly. It removes interference, allowing the body's timing mechanisms to proceed. The human mind does not need to try to fall asleep for this process to work. Effort often delays sleep by reintroducing demand. Silence supports the opposite approach. It creates an environment where disengagement is permitted, not forced. As quiet continues, the boundary between waking and sleep becomes less defined. Awareness softens, thoughts slow, and the sense of self becomes less structured. Sleep does not arrive as an event, but as a gradual release, guided by biology rather than intention. Silence remains present throughout this transition, steady and unchanging. It does not push the body forward or pull it back. It simply holds space, allowing sleep onset to occur naturally, at its own pace, as the day fades and rest takes its place, gently carrying the mind toward deeper stillness. As sleep deepens, silence continues to play a quiet supporting role, even though awareness has largely withdrawn from the external world. Dreams emerge from internal neural activity rather than sensory input, yet the conditions that allow dreaming to unfold smoothly are shaped earlier, during the transition into sleep. Silence helps create those conditions by allowing the brain to disengage fully from monitoring the environment. During sleep, the brain cycles through different stages, each with its own patterns of activity. Dreaming is most vivid during stages when the brain is active internally but disconnected from external signals. Silence supports this disconnection. When the auditory environment remains quiet and predictable, the brain is less likely to partially reorient toward wakefulness, allowing dream states to remain uninterrupted. Neuroscience shows that dreaming relies on the brain's ability to generate imagery, emotion, and narrative without external guidance. Sound can intrude on this process, pulling fragments of the environment into dreams or disrupting them altogether. Silence reduces the likelihood of intrusion, allowing dreams to develop according to internal rhythms rather than external interruption. Silence also supports emotional processing within dreams. Many dreams involve the integration of emotional experiences from waking life. For this integration to occur smoothly, the brain benefits from uninterrupted internal communication. Quiet environments reduce micro-awakenings and sensory disturbances that could fragment this process, allowing emotional material to be explored and resolved within the dream state. From a biological perspective, dreaming is part of how the brain maintains balance. It allows neural connections to reorganize, emotional memories to be processed, and creative associations to form. Silence does not cause dreaming, but it protects the conditions in which dreaming can function effectively. It acts as a buffer between the internal world and the external environment. Importantly, the brain continues to monitor sound even during sleep, though at a reduced level. Sudden or irregular noises can trigger partial awakenings, interrupting dreams without full awareness. Silence minimizes these disruptions. When the auditory environment remains stable, the brain feels no need to shift states prematurely. Silence also influences how dreams are remembered. Dreams that unfold without interruption are more likely to feel cohesive upon waking. While dream recall varies widely, uninterrupted dream cycles support a smoother transition between sleep stages, reducing confusion or abrupt awakening. The human mind does not need to observe or influence dreaming for silence to support it. Dreaming is an internal process guided by neural timing and chemistry. Silence simply reduces external demands, allowing the brain to remain focused inward. As the night continues, silence remains unchanged. It does not participate in dreams, but it allows them to exist fully. The environment stays neutral, offering no signals that require response. This neutrality is what makes silence such a powerful companion to sleep. Dreams rise and fall on their own rhythm, shaped by memory, emotion, and neural activity. Silence holds the space around them, steady and unobtrusive, allowing the brain to wander freely within itself. In this way, silence supports not only the onset of sleep, but the rich internal landscape that unfolds beyond awareness, gently carrying the mind deeper into rest. As sleep settles into its deeper phases, silence continues to serve as a steady background, even though awareness has largely withdrawn from the environment. The body and brain remain active throughout the night, cycling through patterns of rest, repair, and internal regulation. Silence does not guide these processes directly, but it supports them by remaining unchanged, offering no signals that require response or adjustment. During deep sleep, the brain reduces its sensitivity to external input, yet it never fully disconnects. Auditory monitoring remains faintly present, ready to react if needed. Silence minimizes the need for this monitoring. When the environment stays quiet, the brain can remain fully committed to internal processes, rather than repeatedly checking outward. This uninterrupted state supports stability across sleep cycles. The body also benefits from this consistency. Throughout the night, systems responsible for repair, immune function, and hormonal regulation work most efficiently when they are not interrupted by sensory disturbance. Silence helps preserve these uninterrupted windows, allowing physiological processes to follow their natural timing without disruption. As sleep cycles repeat, the brain moves between deeper and lighter stages. In quieter environments, transitions between these stages are smoother. The absence of sudden sound reduces micro-awakenings, brief shifts toward alertness that may not be remembered but still affect sleep quality. Silence lowers the likelihood of these interruptions, supporting continuity rather than fragmentation. Silence also influences how the body maintains its internal balance overnight. Temperature regulation, breathing rhythm, and heart rate all shift subtly during sleep. These shifts rely on steady feedback rather than sudden correction. Quiet environments provide stability, allowing regulation to occur gradually rather than reactively. From a neurological perspective, silence supports long-term recovery. Nighttime processes are not isolated events. They accumulate night after night, reinforcing resilience and stability. By reducing unnecessary sensory engagement, silence helps ensure that these processes can repeat reliably, without being shortened or disrupted. Importantly, silence does not need to be absolute. What matters most is predictability. Consistent quiet allows the brain to trust the environment, reducing the need for vigilance even during lighter sleep stages. This trust supports deeper rest overall, even if brief sounds occasionally occur. The human mind remains uninvolved throughout this process. Sleep unfolds automatically, guided by biological rhythms rather than conscious control. Silence supports this automation by staying neutral, neither stimulating nor signaling change. As the night continues, silence becomes part of the rhythm itself. It is not noticed, not evaluated, and not interpreted. It simply remains, allowing the brain and body to move through their cycles without interference. Toward morning, as sleep lightens naturally, silence continues to hold space. It does not rush the transition or delay it. The night passes quietly, supported by the absence of demand. Silence accompanies the body through rest and recovery, remaining steady and unchanged, gently allowing the processes of sleep to complete themselves in their own time, without disturbance, as the mind remains at ease beneath awareness. As night begins to loosen its hold and sleep gradually lightens. Silence continues to shape how the body returns to wakefulness. Waking is not an abrupt shift from unconsciousness to alertness. It is a transition, guided by internal rhythms and environmental cues. Silence supports this transition by allowing it to unfold slowly, without forcing the body into immediate responsiveness. During the lighter stages of sleep near morning, the brain becomes more receptive to external input. In noisy environments, this sensitivity can trigger premature alertness, pulling the brain into full wakefulness before it is ready. Silence reduces this pressure. With fewer signals demanding interpretation, the brain can move through lighter sleep stages smoothly, preserving a sense of continuity rather than disruption. The body responds similarly. Heart rate and breathing begin to adjust as waking approaches, but these changes are subtle when the environment remains quiet. Muscles do not tense suddenly, and stress-related systems are not activated unnecessarily. Silence allows the body to prepare for activity gradually, maintaining balance rather than shifting abruptly into readiness. Silence also influences how waking feels subjectively. When sound is minimal, the transition into awareness often feels softer and less fragmented. Thoughts emerge slowly. Sensory awareness returns without urgency. This gentle re-entry supports a calmer baseline state, shaping how the rest of the day is experienced. From a neurological perspective, this gradual transition supports regulation. The brain prefers predictable changes over sudden ones. Silence provides predictability by remaining consistent as internal states shift. This consistency allows neural networks to adjust smoothly, maintaining coherence rather than resetting abruptly. Silence also reduces anticipatory stress. Sound often signals tasks, movement, or social interaction. In its absence, the brain has fewer reasons to project forward immediately. Attention remains grounded, allowing waking awareness to form without being pulled into planning or evaluation. Importantly, silence does not delay waking. The body's internal clock continues to guide the transition toward alertness. Silence simply removes external pressure, allowing that timing to unfold naturally. Waking occurs when the body is ready, not when the environment demands it. The human mind does not need to manage this process. Awareness returns on its own, shaped by internal signals rather than external interruption. Silence supports this return by offering a neutral background, free of urgency or demand. As waking completes, silence may begin to give way to sound naturally. Even then, its influence lingers. A quiet transition leaves the nervous system less reactive and more balanced, shaping the tone of awareness beyond the moment of waking itself. Silence does not define the start of the day, but it can shape how the day begins. By supporting a calm transition from sleep to wakefulness, silence helps maintain continuity rather than rupture. The night releases gently, the body adjusts smoothly, and awareness returns without being rushed, allowing the mind to emerge rested, balanced, and steady, ready to meet the day without tension or haste. Silence does not act as a treatment or solution, yet over time it can shape mental health in subtle and meaningful ways. The human mind is influenced not only by thoughts and experiences, but by the environments in which those experiences unfold. Sound-heavy environments continuously stimulate attention and emotional systems. Silence reduces that stimulation, allowing regulation to become the default rather than the exception. Long-term exposure to constant noise has been associated with increased cognitive fatigue and emotional strain. Even when noise is familiar or ignored, the brain must still process it at some level. Silence offers relief from this background demand. By repeatedly allowing the brain to operate in low stimulation conditions, silence supports sustainability rather than intensity. Mental health depends heavily on regulation. Emotional balance, cognitive flexibility, and resilience all rely on the ability to return to baseline after stimulation. Silence strengthens this ability by reducing unnecessary activation. Over time, the mind becomes more familiar with calm states, not because they are forced, but because they are frequently allowed. Silence also supports reflective processing. Many mental health challenges are intensified by constant distraction, which prevents experiences from being integrated fully. Quiet environments allow thoughts and emotions to arise without being immediately displaced. This does not mean rumination is encouraged. It means experiences are given space to settle naturally, rather than being continuously interrupted. From a neurological perspective, silence supports networks associated with self-regulation and emotional balance. These networks benefit from stability and predictability. Quiet environments provide both. Over time, repeated exposure reinforces regulatory pathways, making balance easier to access even outside of silence. Importantly, silence does not remove difficulty or eliminate stressors. It supports recovery between them. Just as sleep does not prevent effort, but makes it sustainable, silence does not erase challenges, but helps the mind remain flexible in the face of them. Silence also reduces cumulative mental load. Without constant auditory input, the brain expends less energy filtering and prioritizing. This conservation supports clarity, patience, and emotional steadiness. The effect is gradual and often unnoticed, but it builds quietly over time. The human mind does not need to analyze or monitor these changes. Mental health benefits emerge through repeated biological responses rather than conscious effort. Silence becomes familiar, predictable, and supportive, shaping how the brain responds to stimulation when it returns. As quiet continues, the mind rests in a state that is neither withdrawn nor strained. Awareness remains present but unburdened. Silence supports mental health not by fixing, but by allowing balance to reassert itself, gently reinforcing the brain's natural capacity for regulation and calm. As sound continues to recede, awareness begins to change in a subtle but important way. Awareness does not disappear, and it does not become dull. Instead, it becomes less effortful. Without constant auditory input pulling attention outward, awareness no longer needs to grip or scan. It settles naturally, resting within experience rather than actively monitoring it. In everyday life, awareness is often directed. It follows sounds, responds to movement, and tracks changes in the environment. This directed state requires energy. Silence removes many of the cues that demand direction. With fewer signals to follow, awareness is free to remain open without needing to choose a focus. This openness feels calm, not because attention is reduced, but because it is no longer strained. Neuroscience suggests that awareness without effort is supported by reduced activity in networks associated with control and evaluation. When sound is present, these networks help decide what matters. In silence, that decision-making becomes less necessary. Awareness remains present, but it is not constantly assessing or prioritizing. This shift supports a state of gentle presence rather than active engagement. Silence also allows awareness to become more evenly distributed. Instead of locking onto specific stimuli, perception spreads across the body and environment in a softer way. Sensations, thoughts, and emotions may arise, but they do so without urgency. There is no need to respond or interpret. Experience unfolds on its own. From a biological perspective, this form of awareness is efficient. It conserves energy while maintaining sensitivity. The nervous system remains responsive, but it is not preparing for immediate action. Silence signals that sustained vigilance is unnecessary, allowing awareness to rest without losing clarity. Importantly, this state does not require practice or technique. Awareness adjusts automatically in response to sensory conditions. The human mind does not need to observe awareness or guide it. Silence does the work by removing excess demand, allowing perception to settle into a stable, low-effort mode. This low-effort awareness is closely related to rest. When attention no longer needs to manage the environment, internal systems can operate more smoothly. Breathing, posture, and internal rhythms align without conscious control. Awareness becomes a quiet companion rather than an active driver. Silence also reduces the sense of separation between observer and experience. Without constant sound reinforcing external boundaries, awareness feels less divided. The mind no longer stands apart, watching the moment. It rests within it. This shift does not feel dramatic. It feels natural, as though something unnecessary has been released. As quiet continues, awareness remains steady without being anchored. Thoughts may pass through gently, sensations may come and go, but nothing demands response. Silence supports this balance by staying neutral, neither adding stimulation nor withdrawing support. In this state, awareness feels continuous and unforced. There is nothing to follow and nothing to avoid. Silence provides a background where presence can exist without effort, allowing the mind to remain calm, open, and settled, gently preparing for the final easing of attention that follows as rest deepens further. As quiet remains steady, the process of letting go begins without effort or intention. Letting go is not something the human mind does deliberately. It is something that happens naturally when there is no longer a need to hold attention tightly. Sound often gives the mind something to manage, something to respond to, something to track. Silence removes that obligation, and in doing so, creates space for release. Holding attention requires energy. Even passive listening involves subtle readiness, a background alertness that keeps awareness slightly engaged with the environment. When silence persists, that readiness becomes unnecessary. The mind senses that nothing is being asked of it. Without demand, effort softens on its own. Thoughts lose their grip, not because they are pushed away, but because there is no reason to keep them close. This release is gradual. There is no clear moment where letting go begins. Instead, it unfolds quietly as layers of effort fall away. First, The urge to monitor fades. Then the need to interpret weakens. Finally, even the impulse to follow thoughts loosens. Silence supports each stage by remaining unchanged, offering no new stimulus to restart engagement. From a neurological perspective, letting go reflects reduced activity in systems responsible for control and prediction. These systems are essential during action, but unnecessary during rest. Silence allows them to step back without being shut down. The brain remains capable, but no longer insistent. Awareness stays present while effort dissolves. Letting go also affects how the body is experienced. Muscles that were held lightly engaged release further. Posture adjusts subtly. Breathing becomes less directed and more automatic. These changes do not require awareness to happen. They are biological responses to reduced demand, guided by the nervous system rather than conscious choice. Emotionally, letting go feels like easing rather than loss. There is no sense of something being taken away. Instead, there is relief from carrying what is no longer needed. Silence provides safety for this release by offering predictability. When nothing interrupts, the mind learns that it does not need to stay prepared. Importantly, letting go does not mean disengaging completely. Awareness remains. Sensation remains. What changes is the relationship to them. Experiences are allowed to come and go without being held, followed, or resisted. Silence supports this by staying neutral, neither inviting engagement nor discouraging it. As quiet continues, the sense of time becomes less relevant. Without sound marking progression, moments blend together. Letting go extends beyond thought into perception itself. There is less interest in what comes next and less attachment to what just passed. Awareness rests where it is without needing to move. The human mind does not need to recognize this shift for it to deepen. Letting go unfolds beneath awareness, guided by the absence of demand. Silence acts as a steady container, holding space while effort fades. As this release settles, awareness becomes lighter, less anchored, and less directed. There is nothing left to manage. Silence has done its work simply by remaining present. Letting go completes itself gently, preparing the way for the final settling that follows, as attention drifts naturally toward rest, without resistance or expectation. As letting go continues, the experience of stillness begins to emerge on its own. Stillness is not the absence of sensation or awareness. It is the absence of demand. When silence remains uninterrupted, nothing asks the mind to adjust, respond, or prepare. Without these requests, awareness naturally settles, like water becoming calm when no longer disturbed. Stillness is often misunderstood as something that must be created or maintained. In reality, it appears when effort is no longer required. Sound frequently prevents stillness by constantly reintroducing movement into awareness. Even gentle sounds create direction. Silence removes direction, allowing experience to rest without needing to orient itself. In this state, the body feels more evenly distributed. Sensations no longer compete for attention. Breathing moves without emphasis. The feeling of having a center softens, replaced by a sense of quiet balance. These changes are subtle and unfold without instruction, guided by the nervous system's preference for efficiency and ease. Neurologically, settling into stillness reflects a reduction in internal signaling. related to action and prediction. The brain remains awake enough to register experience, but no longer prepares for what comes next. Silence allows predictive systems to stand down fully, confirming that nothing is required. This confirmation deepens the sense of stability. Stillness also alters the relationship to thought. Thoughts may still appear, but they arrive without momentum. They do not pull attention forward or demand resolution. They pass through the field of awareness lightly, leaving no trace. Silence supports this by providing no external anchor for thinking to organize around. From a biological perspective, stillness is a state of low expenditure. Energy is conserved. Internal systems align without correction. This alignment supports recovery, regulation, and rest. Silence does not cause stillness directly. It allows it by removing friction. The human mind does not need to recognize stillness for it to deepen. Awareness rests naturally when nothing disrupts it. Silence provides that uninterrupted space. The longer quiet continues, the less effort remains, until even the sense of effort itself fades. Stillness is not a destination. It is a condition that arises when the environment stops asking for participation. Silence holds this condition gently, without defining it or drawing attention to it. Experience becomes simple, continuous, and unforced. As awareness settles further, the boundary between presence and rest becomes less clear. Stillness blends into ease. The environment remains unchanged, and internal rhythms continue smoothly. Nothing stands out. Nothing needs to. Silence remains steady, allowing stillness to persist without pressure. There is no need to hold this state or move beyond it. The mind rests where it is, supported by quiet, balanced by absence of demand, preparing naturally for the final release that completes this gentle journey into rest. As this exploration comes to a close, nothing needs to change. Silence has already done its work. There is no final insight to hold on to and no conclusion to reach. The body and mind have been guided not by instruction, but by the steady absence of demand, allowing everything to settle on its own. Throughout this journey, silence has remained consistent. It has not asked for attention or effort. It has simply stayed present, reducing stimulation and allowing natural processes to unfold. This consistency is what makes silence so supportive. It does not direct, it permits. At this point, awareness no longer needs to follow anything. There is nothing left to explain or explore. The science has faded into the background, and experience remains simple. Breathing continues. The body remains supported. Awareness rests without direction. The mind does not need to stay alert or let go further. Whatever state you are in is enough. Silence does not require participation. It holds space equally for rest, drifting, or sleep. If thoughts appear, they can pass. If sensations shift, they can shift. Nothing interrupts the quiet foundation beneath them. Silence remains unchanged, offering stability without effort. This is not an ending in the usual sense. It is a gentle completion, where nothing is added and nothing is taken away. The day, the night, the moment all move forward naturally, without needing to be marked. You do not need to remain here or move on. Silence does not ask you to choose. It simply stays, allowing everything else to do what it naturally does. As this final moment settles, you can let awareness soften as much or as little as it wants. Silence remains steady and neutral, holding no expectations, offering no instructions, allowing rest to take its place quietly and completely. Good night.